Another system that we're going to explore here, and I want to see what happens to illustrate another possibility that we'll see. So let's graph both of these lines. We can manipulate the equations to slope-intercept form, or we can look at its y-intercepts, x-intercepts right now, and that's all good too. So it's x-intercept. This x-intercept here happens when I set y equal to 0. And in that case, my x-intercept will be 3/2. Looking for my y-intercept happens when I set my x equal to 0. And so I get a y-intercept of 3. So we can graph that out. 3/2 is 1.5. 1, 2, 3, 3. And there's a rough graphical representation of the first line. The second one, we can also graph through intercepts. Its x-intercept happens when y is 0. So I have an x-intercept of 3/2. My y-intercept happens when my x is 0, and that happens when y becomes 3. Graph that, and if I graph that, you're going to notice that I have the exact same intercepts and that I have a line that is exactly on top of the other line. So this is a graphical representation of a system that has an infinite amount of solutions. 2 points I want you to be aware of. Well, how do we write that solution set down? How do we say what the solutions are? Well, one way that we can do that is we can write it down there is a notation there, so let me explain this notation to you. This notation tells me is one, I have a solution set. Those brackets on the end represent solution set notation. Within those brackets tells me what the solutions are. And this is read such that the coordinate xy such that 2x plus y equals 3. Basically tell me any x and y that satisfies this equation is a solution to this particular system. I could also write the solution set similarly. Any coordinate point xy such that 4x plus 2y equals 6. So if I can find any xy that makes this true, I have a solution to this particular system. So if I have an infinite amount of solutions, does that mean that every coordinate pair is a solution? Well, no. Only the coordinate pairs that are on this line. For example, the point 0, 0, that's a coordinate pair. That's not a solution to this particular equation. So although I have an infinite amount of solutions, I don't have all the solutions. And that's something that we want to kind of pay attention of. And some of you may have also noticed when I had my original system here written on the board, some of you kind of recognize that, well, this equation is really twice that of that first equation. What if I multiply that first equation by 2 to both sides? If I did that, I would wind up with that exact wording of that second equation. So those are some clues to help us kind of get an idea of what might be happening.